Welcome to Backup Exec 2012, Agent for Applications and Databases. If you're following along in the course material, we're in Lesson 2. In this lesson, we'll discuss the Agent for Application and Databases from a very high-level overview, and then we'll go into how to install this agent, and we'll talk about the applications that are supported by this agent. In a nutshell, if you're familiar with older versions of Backup Exec, we have really tried to simplify installation. So instead of having an agent for Exchange and a separate agent for SQL and for the different applications, it's all one agent now. So we'll take a look at installing it. You may have to install the same agent multiple times if you're backing up different types of data. So we'll talk about the databases that we support. And then we're going to take a deeper dive into the agent for Microsoft Active Directory, why you need this agent, the requirements for it, and what it protects. It allows you to restore individual items from Active Directory. So we back up Active Directory as a whole, but you can restore an individual user using this agent with its original GUID. So we'll take a look at the details for that. Let's start with the overview and the fundamentals of the Agent for Applications and Databases. Anytime that you back up a database, databases have two main portions, and that is the database itself and the transaction logs. And when users access the database, they're accessing it through whatever interface is presented to them. When you access the Backup Exec database, you're using the Backup Exec console to access the database. It still is a database. So it still has a database, it still has transaction logs. The way databases get their speed is when users are accessing the database, they're making entries into the transaction log. Logs are then committed to the database itself. In some applications, the only way that logs get committed to the database is to run a backup. A good example of that is Exchange. So if I want to clear that transaction log, I must back up both sides. I must back up the database and the transaction log so that the transaction logs are committed to the database, and then Backup Exec can get the data out for backup. So the applications themselves, like the Backup Exec console, is reading from the database, but it is also involving these transaction logs. The agent for applications and database understand this structure, and that in many cases both sides of this structure have to be dealt with. In SQL, we send that forward for you to see, and we'll take a look at that when we get into the SQL lesson. So it depends on the type of database you're running and how it's configured, whether or not the backups have to touch both sides. In some cases they do, so your job definition would need to include a schedule for the transaction log and a schedule for the database. Not all applications work that way. Exchange, for example, understands that they both work together, and the agent for applications and databases will adjust itself accordingly. The idea behind these agents is that they allow me to combine the different types of backups so that I can say I want to back up my Exchange server or my SQL server as a whole, including the C drive and any volumes which are housing the database and the transaction logs. So it's a very centralized management. In many cases, if you have a database administrator or a DBA, DBAs are often very hesitant to allow backup software to back up the database. Typically, they will want to write a script that dumps the data out and have the backup administrator simply back up the dump. In the case of SQL, that's a file with a BAK extension. But that's very difficult for anyone but the database administrator to restore. So one of the big advantages of using this agent is not only am I using the agent to do the backup, but anyone who understands Backup Exec can also restore that database to the point of the last backup. Most internal database applications, while they do allow you to run a backup from a script, they can only write to disk. So the agent for Backup Exec, agent for applications and databases, allows you to back up that data to disk and duplicate it to other disks and use tape. So it allows many more backup options than the native application does. I can also take advantage of Backup Exec's scheduling. I don't have to run a script. I can just schedule the Backup Exec job to back up any database that's covered by this agent. I can also back up the databases that are supported hot, meaning that the services are up and running. You don't have to run a script that shuts the database down and backs it up. The database can stay up and running. That's very important when it comes to massive production databases like Exchange and SQL. We support automatic transaction log maintenance, so the agent understands that the transaction log has to be committed and that the whole thing has to go out so that Backup Exec can back it up. If you don't do that transaction log side, the transaction logs will continue to grow and grow and grow until they fill up the hard drive. So Backup Exec agent for applications and databases understands that those transaction logs need to be deleted after they have been committed to the database. If you're using SQL, that's known as a truncate. If you're using Exchange, that's known as a flush. We also support various backup methods, so you can back up the database itself as a full backup. You can do a differential against the database, which is only the things that changed. And if you're running SQL, you can back up just the transaction logs. We do allow you to roll the transaction logs forward and back based on a named transaction or a date and time stamp using this agent. The biggest thing to understand about this agent is that it uses the native application protocols, the APIs, for the database's proprietary tools to do the backup. So there is no difference between using the Backup Exec agent to back up a database and what the DBA's script does. They're using exactly the same functionality, exactly the same methodology to access the database and ask the database for the data without corrupting the database. So the agent for applications and databases will always use the native tools for the database to ask nicely for the data. So there will be no database corruption. The screenshot here depicts the functionality of this at runtime. So at the top of the screen, you see the Backup Exec server with its database, its own database and catalogs. At the time the backup runs, the Backup Exec server is going to go to the agent that's running on the database server and request the agent to gather up the data. The agent is going to then go to the volume shadow copy service to ask for a snapshot to be taken. And the volume shadow copy service goes through the application API calls to quiesce the database. Quiescing the database is the function of making sure that there is no transaction in progress so that when we take the snapshot, we capture everything. If there were a transaction in progress and we took the snapshot, we would be missing that transaction. So the application API calls quiesce the database, and they're responsible for taking the snapshot that then the agent for Windows uses to gather up the data and send it across to the Backup Exec server. So all the control information that the database uses natively is left intact, and the database can continue to function as it always does. So the big things to take away from this are that the agent will always use the native mechanisms to back up the database, but it's using a snapshot technology or the volume shadow copy service that's native to Windows to be able to back up that database. The volume shadow copy service has the option of calling other service providers to take the snapshot that will be used for the backup. So in the screenshot we're looking at now, the requester is the Backup Exec agent. So the server kicks off the job and says, agent, hand me the data. The agent is going to go out to the volume shadow copy service and say, we need a backup. Please provide us a snapshot of this open database. The volume shadow copy service has several different options it can use to create that snapshot. Several of the databases have their own snapshot providers. SQL is a good example. That SQL has its own snapshot provider, so VSS will go down the list and look to see if anyone is available to take that snapshot for VSS. So the system provider is volsnap.sys. That's the VSS snapshot provider. The software provider is the SQL provider, if SQL is there. Active Directory also has its own snapshot provider. So there are several snapshot providers that are specific to the application. Depending on where the database is installed, you may also have a hardware provider. There may be a snapshot provider on the NAS or SAN device that is housing that database. VSS will go to that hardware provider and say, you create the snapshot. So as a detail on how this whole process happens, at the time the backup kicks off, the requester or the Backup Exec agent that's running on that database server is going to request the backup and request the snapshot. It then goes to the snapshot writers and says, we need the data, please provide us a snapshot. The writers are going to go to the snapshot provider, whether it's the system or hardware or software, and say, please provide us a snapshot. At that point, the snapshot provider must wait for the database to be quiesced, meaning there can be no input or output for just a few seconds while that snapshot is created. So then the snapshot is taken. VSS will commit the snapshot to a cache file and come back to the requester and say, in this case the agent for Backup Exec, and say, here's your snapshot. You may now back up the database from the snapshot. Microsoft has several best practices in this area, and one of them is that if you're going to do database consistency checks, you should do the consistency checks against the snapshot rather than the active database. The Backup Exec agent is aware of those best practices and follows them, particularly in the case of Active Directory. Active Directory is really just a database, and we will always run, the agent will always run consistency checks against the snapshot of Active Directory. So this gets us the snapshot. At this point, the Backup Exec agent is now able to go through VSS and through the writers to back up the data that's in this snapshot. So once the database is quiesced, the snapshot is created, the agent can go out and back up all of the data that's in that snapshot. Once that completes, the agent will always run a database consistency check. At the end of this process, the agent will alert VSS that the backup has completed and that the snapshot can be deleted. So the cache file is released and deleted, and that way that space is available for the next time a backup occurs. In database terminology, you have several different types of backups that are similar to the backups we see in file systems. So in a file system backup, a full backup backs up all the data that's selected, and it resets. It either resets the change journal or it resets the archive bits. In database terminology, that concept is the same, but it applies only to the database. So when I back up a database, I'm doing a full backup of the database. It depends on what type of database it is, whether or not that involves transaction logs. In the case of Exchange, then when we back up the Exchange Information Store database, that means that the agent will commit the transaction logs from the transactions from the transaction log to the database, back up all of the stuff in the database, and flush or empty out the transaction logs. In the case of SQL, a full backup applies only to the database. It does not touch the transaction logs. If I want to do a partial backup against a file system, I can do an incremental backup, which means that I'm backing up only the things that have changed since the previous backup. And it resets. It resets either the change journal or the archive bits. In the case of a database backup, you have two different backups that you need to run to give it the equivalent of an incremental backup against a file system. Those two backups are a log backup, which is backing up the transaction log, and it is resetting. It is committing all of the transactions from the transaction log to the database and emptying out the transaction log. In SQL terminology, that's a truncate. That touches only the transaction log, though. In order to do an incremental against the database, I must also run a differential backup against the database, which says back up only the things in the database that have changed since the last backup. So very similarly to an incremental backup that resets the change journal or archive bits, a log backup resets the transaction log. You also have on a file system a differential backup, which means that I'm backing up the changes since the last full backup. In database terminology, what that means is I still must touch both sides of the database if it's SQL. I must deal with the transaction log and the changes to the database. In this case, you would do a log no truncate, meaning that you're backing up just the transaction log. In Backup Exec 2012, the only time you can run a log no truncate backup is if you're running a one-time backup. So that's a very special backup in Backup Exec 2012. If you run a log no truncate backup, you're touching only the transaction log. So you should also run a backup that touches the database, in this case a differential backup, so that you're backing up the changes to the database. In SQL, if you only run full backups, you're not touching the transaction log. And Backup Exec will send you a warning after a certain number of fulls have run that tell you that you should also be backing up your transaction logs. So Backup Exec has a lot of intelligence built into it that understands that there are different types of backups that touch the transaction log and the database, and that if you're not a DBA, you're a Backup Exec administrator, we don't expect you to know all that. So Backup Exec has a lot of intelligence built into it to help you build these backups appropriately. To install the agent for applications and databases, I can go to the Backup Exec button and click Installation and Licensing, Install Options and Licenses. What you're looking for here is the agent for applications and databases. This agent actually is a combination of many agents, and you see those listed on the far right of this slide. It includes the agent for Enterprise Vault, the agent for Lotus Domino, the agent for Exchange, the agent for SQL, the agent for SharePoint. You need to have one agent for applications and databases for every different application that you're backing up. So if I am backing up an Exchange server and a SQL server, I should install the agent for application and databases with 2 license keys. In older versions of Backup Exec, these were separate agents and separate license keys for each application. So we've tried to simplify the installation process, but please understand that you must have an agent for applications and databases per application per server. So if I have SQL installed twice on the same server, I would need 1 agent for applications and databases for that SQL server. So it's per application per server that this agent is licensed. When you install this agent, by default, it will also include the snapshot process that we've talked about earlier. So by default, the advanced open file options will be marked to use the snapshot technology. The best practice is to leave this at automatically select. If you are backing up only Windows boxes, you can tell it to use the Microsoft Volume Shadow Copy service, and then the drop-down menu that you see on this screenshot will become active. This drop-down menu includes automatic, which is the default, that allows VSS to go through its natural process of looking for any other provider who can take the snapshot. But the drop-down also includes use a hardware provider or use a specific provider. Best practice here is to either automatically select or to allow VSS to go through its automatic process. Processing logical volumes for backup one at a time may be a box that you need to unmark depending on how your database is configured. By SQL best practices, SQL should be installed so that the database is on one volume and the transaction log is on a different volume. In that instance, you should unmark this checkbox so that the snapshots are created for both volumes at the same time, so that they will be in sync. So if I'm backing up a SQL server that is installed to best practice, you should unmark this checkbox. Enable checkpoint restart is markers that Backup Exec puts into the snapshot so that if the backup fails, we can go to the last marker and continue from there. This is new to this version of the product. If you are backing up SQL Server 2003 and you're doing it so that you can redirect or back up the database from old hardware and reinstall it on new hardware, SQL 2003 or Exchange 2003 did not have snapshot providers native. In those instances, you need to make sure that you uncheck the box that says use snapshot technology. So if you are backing up Exchange 2003 or SQL that is on an Exchange 2003 server and you want to restore those to a different location, please refer to the tech note that you see on this slide. We have lessons for each of these databases. In this case, we're looking at an example of Exchange. Once you have this agent installed on the Backup Exec server, then you can set the options for the type of database that you're backing up. It's important to understand that when you install the agent for applications and databases, you are simply opening up the functionality on the Backup Exec server to be able to back up whatever databases we support. The agent for Windows must also be installed on the machine that you're backing up. So just because I put the agent for applications and databases on my Backup Exec server does not mean I can back up the Exchange server. I must also have the agent for Windows installed on that Exchange server or SQL or SharePoint or whatever server you're backing up. Any machine that you want to back up must be running an agent. When you look at the selections for the backup job, you will know that the agent for applications and databases is appropriately licensed, because when you drill down into the details of what can be backed up from that server, you will see the application with a little database icon. In this screenshot, it's the Exchange Information Store, but you'll see the little drum or database icon. You should also see the pieces that are included in that application. In this case, it is mailbox databases and the public folder database. You'll notice that you can't drill down farther into this, that you need to back up the database at the highest level possible. All of the dynamic inclusion that we have talked about for Backup Exec still applies to databases. We don't let you drill down and back up individual pieces. However, on the restore side, because of this agent, you can drill down into the backup and restore individual email and individual mailboxes when you back up Exchange, or individual files when you back up SharePoint. So from the backup standpoint, we don't let you drill down very far. On the restore side, you can see the details. The different applications that are supported by this agent for applications and databases include the Enterprise Vault agent. Enterprise Vault is a semantic product that allows you to archive either Exchange, Lotus, or file systems to vaults that's drive space that's managed by Enterprise Vault. Backup Exec can then back up those vaults that are managed by Enterprise Vault. So the agent for Enterprise Vault is how you back up the vaults that have taken the data off of your Exchange or Lotus or user data file system and stored that data into this drive space that Enterprise Vault is managing. So the agent for Enterprise Vault allows us to back up the Enterprise Vault databases that keep track of where the data came from and where it's living now. It allows Backup Exec to restore individual items back into the vaults and deal with the transaction logs on the databases appropriately, and allows us to groom the vaults as the Enterprise Vault rules dictate. So once data goes into the vaults, it is only allowed to stay there for a specific amount of time. If you back it up, it can also only live in the backup for that specific amount of time. So Enterprise Vault will send Backup Exec a message that says, this data needs to go away, it has expired, and when your backups expire, make that data go away from the backup as well. We also support the agent for Lotus Domino, which allows Backup Exec to deal with all of the Domino attachment and object services, all of the NLO files, and the transaction logs for Lotus Domino. This agent also supports Microsoft Exchange Server. We have an entire lesson on Microsoft Exchange in which we discuss backing up Exchange as a whole, but being able to recover individual mailboxes and individual mailboxes using the granular recovery technology. In this version of Backup Exec, when you restore email, it is restored to a PST file. In older versions of Backup Exec, it was restored directly through Outlook. This agent allows me to select the databases or the storage groups that will be backed up and recovered. And on the restore side, it allows us to redirect those storage groups or databases. You can also restore individual databases or storage groups from non-snapshot backups. That's very important, and we'll talk about that in the Exchange lesson. Other applications that this agent supports include SharePoint. You can back up and restore SharePoint regardless of which server the pieces are installed on. SharePoint is typically a distributed installation, meaning that I may have an IIS server that is presenting the web pages for SharePoint. I may have a SQL server that's housing the SharePoint databases, and I may have a NAS or SAN device that is housing the files that SharePoint is sharing, the doc and PPT and XLS files. The agent for SharePoint for Backup Exec allows Backup Exec to query the web server and say, where are the other pieces of SharePoint? And so the agent for Backup Exec will find all of the SharePoint servers in what's known as the SharePoint farm and allow Backup Exec to back up all the pieces of SharePoint in such a way that they're synchronized and they can be restored or redirected as needed. But it also allows granular recovery technology, so you can restore individual web pages, individual wiki pages, individual documents that were backed up as from SharePoint as a whole. You can restore individual pieces and redirect those pieces as needed. This agent also supports Microsoft SQL. It supports database backups, transaction log backups, as well as full database recovery and replacement. It also allows you to redirect SQL databases, which SQL typically doesn't do very well. It automates the restore of system databases. We have an entire lesson on SQL, but in a nutshell, there is one database in SQL known as the master that is the configuration for all of the production databases. On the recovery side, master must be restored first, and then you can restore the other databases. This agent for Microsoft SQL Server is smart enough to say if you're recovering an entire SQL server, you need to restore master first and then the others, and it just does the process. You as an end user do not have to know that that's the process that has to take place. So it is a very much simplified recovery of SQL Server. We also support simplified disaster recovery on the SQL Server, which automates the entire recovery process. And this agent does allow you to redirect SQL databases. The agent for Oracle applies whether Oracle is installed on Windows or Linux. It allows us to back up that Oracle database using RMAN scripts that are generated in the background. By default, Oracle does not have the APIs into the database, so this agent generates the same scripts that the DBA would generate. So it's sending the scripts to the database to back it up using the database's native backup capabilities. It does support multi-data streaming, meaning that we can break the database up into smaller chunks and back it up concurrently, so it's a much faster backup. And that we do also support recovery of the catalogs for Oracle itself. It doesn't matter whether Oracle is installed as a standalone or as the real application cluster. This agent supports all the different versions of Oracle. In this topic, we discussed the agent for Microsoft Active Directory. Active Directory is truly a database, but it's a very special database. And there are several applications that are heavily tied to Active Directory. When you create users in Active Directory, it assigns a globally unique identifier to those users. That GUID is how Active Directory understands logins. So when you press Control-Alt-Delete on your laptop and you log into Active Directory using your username, Active Directory says your username is really this GUID. This agent for Active Directory allows you to back up Active Directory as a whole, but recover individual pieces like users with their original GUID. That's particularly important when we look at Exchange. Microsoft Exchange mailboxes are heavily tied to that GUID. If you were to delete a user accidentally from Active Directory and realize that you deleted the wrong user, recreating that user will not recreate their access to the mailbox, because when you recreate the user, it will have a new GUID, and Exchange says it may be the same name, but to me it's a different user because it's a different globally unique identifier. So this agent allows you to protect Active Directory as a whole and be able to back it up and restore it and redirect the restores as a whole, but it also allows you to back up any item in Active Directory, a group, a user, any piece of Active Directory, and restore that individual item with its original GUID. Active Directory is the traffic cop for your network. If you should have a hardware failure of your domain controller, then users can't log in and they can't access data across your network. So in that case, you would have to be able to restore the entire Active Directory server. Active Directory is a database as well, and it is possible for that database to get corrupted or have pieces deleted of it unintentionally. So if you had deleted something, you should be able to restore it. Traditionally, restoring Active Directory is a long and difficult and involved process. There are two types of Active Directory restores. A non-authoritative restore says that I am restoring my domain controller, but I'm not restoring Active Directory. And I will let Active Directory replicate back in from other related servers. The default for Active Directory is when you bring up a domain controller, the first 3 servers that join the domain will have a copy of Active Directory replicated from the domain controller out to the first 3 servers that join the domain. The administrator can also force replication. Exchange will also have a copy of Active Directory. If you have to recover a domain controller, in most cases, it is a best practice to do a non-authoritative restore. I want Active Directory to replicate back in from the other sources so that it is the most current version of Active Directory available. If I only have one domain controller, or my data center burned to the ground and I've lost all my servers, then I have to do an authoritative restore. An authoritative restore is when I recover the domain controller and Active Directory, and that becomes the master copy of Active Directory that will then get replicated out to all the other servers that would have a copy of it. So what I'm doing is I'm removing any changes that happened to Active Directory since my last backup. Knowing which restore you need to do is important for how the restores occur. The easiest answer is to use simplified disaster recovery so that you can just recover the entire domain controller in one step. If you're going to do the long method of recovering Active Directory, I can do a non-authoritative restore to bare metal. That's where I'm recovering the domain controller. I need to do a disaster recovery on it, and I'm going to let Active Directory replicate back in. On an authoritative restore, I'm going to restore my domain controller, and I may need to restore individual components of Active Directory, and that becomes the master copy that replicates back out. The traditional process for doing this is a long, involved process. So on a non-authoritative restore, this is if I took Backup Exec out of the picture, on a non-authoritative restore, I'm going to have to reboot my domain controller into Directory Services Restore mode, restore system state, reboot the machine, make sure that it's on the domain, and let Active Directory replicate back in. For an authoritative restore, if Active Directory has become corrupt or I've had pieces deleted, I again must reboot the domain controller into Directory Services Restore mode, restore system state, unplug the network cable, and reboot the machine. At that point, I can use ntdsutil to elevate the objects in the server to recover and make it the master copy, reattach to the network, and let that all go out. So it's the master copy that replicates back out. You'll notice here that it is several reboots. This process varies whether you're on Server 2003 or Server 2008. Microsoft has attempted to make this process easier in 2008. It is still, however, a difficult process. And many times the best answer is, if at all possible, just to do a non-authoritative restore and let Active Directory replicate back in. If Active Directory has been corrupted or deleted, this agent, the Backup Exec agent for Active Directory, helps you with this process because you don't have to go through all of this. You can recover just the portions of Active Directory that were corrupted or deleted. So the traditional method is very tedious, is very difficult. It requires a full restore of system state, which generally means that it's not going to want to change hardware. It typically takes a great deal of time and knowledge. It requires at least 2 reboots and the use of system tools in the case of an authoritative restore. And you also must know, in the case of an authoritative restore, when to unplug from the network and when to plug back in. This is a very stressful situation if you're in this situation. So the agent for Microsoft Active Directory eases this situation greatly. We try to automate much of this process for you. So this agent is a part of the agent for applications and databases. It is separately licensed. So it is now called the agent for Microsoft Active Directory. What you're seeing on the screenshot here is the restore side. You back up Active Directory as a part of system state. So when I back up the domain controller, you must make sure that you're backing up system state, and you can only back up system state as a whole. With this agent on the restore side, you can drill down into that system state backup and restore individual items that exist in Active Directory with their original GUID. So this is a very granular capability that you don't have in any other methodology. The client system that you're backing up must be running the agent for Windows, which is included when you purchase the license for the agent for Microsoft Active Directory. It must be a supported version of Windows, meaning Server 2003, SP2, or newer. So that includes Server 2008 and Server 2008 R2. You must be sure that on the backup side you have the option marked to use granular recovery technology. That option is marked by default. And I cannot restore individual objects if I am backing up a read-only domain controller. Read-only domain controller means that we can back up the data, but we can't restore it. You can't write to read-only domain controllers. You need to purchase one agent for applications and databases for each Active Directory server that you intend to protect. So if you only have one Active Directory controller, you would just need one license. If I have multiple Active Directory domain controllers, I would need a license for each one that I wish to use this capability. But because Active Directory is replicated around, you wouldn't technically need to use this capability on all of them. The agent for applications and databases includes an agent for Windows that needs to be installed on the domain controller that you wish to protect. Internally, this agent uses the VSS to create a shadow copy of system state, and that will include Active Directory. On the restore side, we use ADAM, or Active Directory Lightweight Directory Services, ADLDS, to do the restore. I can restore individual objects with their attributes. You can restore tombstoned objects. The tombstone area of Active Directory is similar to the recycle bin for the operating system. So in Active Directory, if I delete a user account, by default, it's not really removed. It's sent to the tombstone area just like a file you delete is sent to the recycle bin. The default for the tombstone area is it remains there for 30 days. That default can be changed, but I can recover from the tombstone area if I'm within that 30-day period using Active Directory itself. So if I deleted a user account and said, oh, no, that was the wrong user, I could recover it from the tombstone area. Backup Exec will also allow you to restore items that were in the tombstone area if the tombstone lifetime has not passed and it has not been purged as a result of that item becoming expired. Backup Exec agent will take snapshots of the Active Directory database, and then we catalog everything that's in that snapshot and able to do the granular recovery restore side. In my backup definition, when I back up that Active Domain Controller, I need to go in the backup definition to Microsoft Active Directory and be sure that the checkbox for Use Granular Recovery Technology is marked. It will be marked by default, and Microsoft recommends that any time that you back up Active Directory, you should do a consistency check both before and after the backup has completed. Backup Exec follows those rules for Microsoft, and that we do the consistency check against the snapshot of Active Directory. By default, the backup job will continue. If the consistency check fails, you will get an alert in the backup job that it failed and that you may need to use the Microsoft tools to repair your Active Directory database. Active Directory can only be backed up as a full backup. This is also true for system state. So if your backup definition said that we're going to do a differential or incremental against this domain controller, Backup Exec will follow that for the files, but system state and Active Directory will always be a full backup. It can't back them up as anything else. You can also set the defaults for Backup Exec as a whole so that the defaults are replicated in any new job that you create, and then you can override them in a new job if you choose to. On the backup side, you will see that you are backing up system state. If you're backing up system state and the C drive, you probably have enabled Simplified Disaster Recovery, and the banner that you see at the top of this screenshot shows Simplified Disaster Recovery as on. You can drill down in system state and see what system state includes, but you'll notice that you cannot mark or unmark any portion of system state. System state can only be backed up as a whole. On the restore side, we allow you to drill down and restore individual items. Any GRT-based backup, any backup that is doing granular recovery technology should be written to disk. It is the most efficient, and it is the most efficient to do the restores. If you should write GRT-based backups to tape, on the restore side, you must restore the entire database. In this case, it is Active Directory, before you can restore the little pieces and parts. The entire database will go into a path that you name at the time of the restore. The default is C:\temp. The best method is to do all GRT-based backups to disk, and then you can simply restore individual pieces of, in our case, Active Directory from that disk-based backup. When you do a restore of Active Directory, you can drill down and see the individual items, see individual groups and users. When you restore a user account, it will reset the password flag in Active Directory that will tell you that you must reset the user's password after the restore has completed. It doesn't actually reset the password, it resets the flag that pops the warning to the administrator that the user's password needs to be reset. If the item was purged, if the Active Directory item was in the tombstone location, it's converted to a tombstone. When the tombstone expires, that object gets deleted permanently. The Backup Exec agent will allow you to restore tombstoned items from any backup. So in this lesson, we have talked about the agent for applications and databases, how to install that agent, how it's licensed, and that agent includes an agent for Windows that would be installed on the server that's running the application or the database. We've talked about the applications that are supported by the agent for applications and databases, and then we've drilled down and looked into the details of how the agent for Active Directory functions to back up Active Directory as a whole, but allow you to restore individual items to Active Directory.